All right, let's do 21 through 25 in this video. Line segment A prime, B prime, whose endpoints are 4, -2, and 16, 14, is the image of AB after a dilation of a half. So this is after the dilation of a half. What is the length of AB? Well, to do this, first we should probably find out the length of A prime, B prime, whose points are given. And we know if we want to find the length, all we have to do is use the distance formula. So we'll start by writing that out. It's x1 minus x2 squared plus y1 minus y2 squared. So our distance is going to be equal to, well, let's just plug some stuff in. This would be 4 minus 16 squared plus -2 minus 14 squared. Distance is equal to square root of, let's see, that would be -12 squared plus -16 squared. All right, let's just keep this math going. This is the square root of 144 plus 256. Sorry, that's a 16. That is going to be the square root of 400, and that is going to give us a distance of 20. So here's what I'm going to write. A prime, B prime has a length of 20. But we want to find out what AB is. And remember, that's before the transformation. So if we know that we're going to have a dilation that is 1/2, this is a half of as big, right here, this is half as big as what AB was. So if you look through these options, all you have to do is figure out that it's answer number 4. AB is 40, and half of 40 is 20. Check. All right, number 22, let's move on down. All right, let's also erase this crapola. I'm done with you. Out. Okay, it's not erasing, whatever. Given triangle ABE and CBD below, we know that DB is congruent to BE. All right. Which statement is needed to prove the triangle ABE is congruent to CBD using side-angle side congruence? Well, you might remember, but for a question like this, it might be smart to actually redraw these and separate them. All right. So what you're trying to do is prove that ABE, which looks like this, is congruent to triangle CBD, which is actually like on its side right here, which is CBD. All right, we're trying to prove this. Now, what's given is that DB is congruent to BE. So we have one side that's congruent in both these triangles. Now, the next thing you know is that B is congruent to B, and that is the reflexive property. All right? And here's where the hard part comes, okay? So we just mark what it is, and we're trying to get side-angle side congruence. Well, we know to get side-angle side, we know we need AB and BC to be congruent. But if you look through the answer choices here, at no point does it say AB is congruent to BC. That's not here, all right? We need AB to be congruent to BC, and it's not in the answer choices. But if you look a little closer, check this out. If you look at your original drawing, all you have to do is know this. If you want AB to be congruent to BC, all you have to do is add this part to both of them. All right? So if AD is congruent to CE, then we know that the whole thing is going to be congruent when you add them together. So if this is 5 and this is 2, well, this is also 5 and this is 2, so they will be congruent. So that's all you had to put here. This little piece will answer for what you're looking for here. Huh? See what happened there? So it's AD is congruent to CE. You just had to add that piece to make them congruent. But the big thing here to remember is redraw your triangles. It makes it much easier. Next problem, number 23. So for question number 23, it's kind of an annoying question. It tells you that the diagram below BC is the diameter of circle A. Then it tells you point D, which is unique from points B and C, which just means it's not on B and C, is plotted on circle A. So we don't know where D is. It's anywhere on there. All right. Which statement must always be true? So this is what we could do. Let's just like try out all these answers. So let's make a random point D, which is right there. And we'll make this triangle. Now the first one says that BCD is a right triangle. And I'll tell you actually, this is the answer. We learned that if we have a triangle inscribed in a circle, this is a triangle inscribed in the circle, with the hypotenuse as the diameter, And then we know that this is a 90-degree angle. So this is something that they actually put on the Regents a lot. So this is actually answer number 1. When you inscribe a triangle in a circle and the hypotenuse is the diameter, it's a right triangle. Now you could have tried the other ones, but if you looked at BCD the way we drew it, is this a right triangle? I mean, is this an isosceles triangle? Do two sides look the same here? Absolutely not. So you could take that out. Now the next one says that triangle BAD, so you'd have to draw this, is similar to CBD? Oh my God, so that makes no sense. It's telling you that these two triangles, BAD, is similar to this bigger triangle, which they don't even look like they're the same shape, so of course they're not similar. Take that guy out. And the next one tells you the same thing, but they're congruent. BAD is congruent to, what's the next one? CAD. So it's saying that this triangle is congruent to this triangle. Obviously not. The answer was number 1. And the last one, number 24. Check it out. All it's asking you to do is solve for angle E, and it tells you that CE is congruent to BE in the givens. All right? Well, if we know that this is a parallelogram, ADCB, let's just start filling in some angles. Well, it tells us the angle D is 112, so we know opposite angles are congruent, so that's 112. We know right here we have a linear pair, so we subtract 180 and we get 68 degrees. Now, since this right here, what we got right over here is an isosceles triangle, we could say that this is 68 degrees because those are my base angles. Let's just do the triangle sum, 180 minus 68, and you get 44 degrees. And that's all you had to do to get this one. Nice and simple. That's how you done. All right, that's it for this video. Peace out.